right, going through this, 6.8 talks about, well, we're going to look at graphs, but just zoom in on particular pieces. Like X-Intercept, just like the warm-up, you've already been exposed to this. We've talked about how X-Intercepts, you got to be aware for the final exam that you might see the word 0, which means the same thing. So be aware of that in directions. Also be aware, we're looking for a point, X, some kind of number, comma 0. You know how picky I am about the notation. Y-Intercept. Y-Intercept is a point, 0, comma y. A local maximum. When we talk about local maximum, it's some sort of, I'm going to call it a peak. If I'm talking about a mountain range, it'd be like the peak of a mountain. And then you have valleys in mountains as well. So a local minimum looks like a valley. I'm going to give an example of what both of these look like. So a picture off to the side. If I have some type of function, a peak or a maximum, a local max, is something that looks like a peak in a mountain. A valley would be a low point. And I'm just abbreviating it with max and min. So tonight's homework, I just want you to estimate, okay, where is that maximum point? Where is that minimum point? And both of these are called turning points. A turning point is when we change from going from increasing to decreasing or vice versa. So it's a point at which we change from increasing to decreasing. Or vice versa. And when I say vice versa, from decreasing to increasing. So let's see if we can identify the pieces to this graph. Can we guess where the y-intercepts are? Sometimes it's not so easy. Like, there's definitely a perfect one in the next picture if you haven't seen it already. But 1, 0 works. I'll go through how to find these other x-intercepts in a little bit, but maybe let's pick out the perfect stuff first. What's a perfect y-intercept? 0, 2. Notice from the equation I should have been able to identify that also. The constant term. 0, 2. Local maximum. Where's the peak? 0, 2 again. And then a valley. Is that perfect? I don't know. Oh, I think it is kind of perfect. 3, negative 2 is pretty nice. My mistake. 2, negative 2. Okay. Using synthetic division and then the quadratic formula. These were the other two x-intercepts. So we're going to move to modeling with quadratic functions and how to write quadratic functions if we know a couple characteristics. This reviews our Chapter 5 knowledge for the final exam, where, okay, what was vertex form? What was intercept form? And if I'm given a graph, how can I create the equation? We've seen some warm-ups like this, so it's not going to look too out of the blue to you, but we're just going to refine our skills on these equations now. Okay, so first off, you have the following on your piece of paper for your notes. And what you're going to have for homework tonight is you're going to need to write a quadratic equation or a quadratic function in vertex form for the parabola. So you got to figure out what was vertex form. So vertex form was y equals a times the quantity x minus h squared plus k, where h and k represented the vertex. So if 2, -3 is the vertex, then I'm going to use that for h and k. Notice what happens though whenever you plug it in with the equation. Whatever the x-coordinate is, we're going to have the opposite sign in our equation. So this is a +2, so here I'm going to just have -2. So what happens is the following. I'm going to have, and as you're writing this in your notes, you can put down, because we had h there, you can put down y equals x minus 2 squared and then plus k, but you're going to see how I replace some of these variables in this presentation. So in the place of h, I'm going to put a 2. In the place of k, because k keeps its sign, I'm going to put a -3. And now we're going to learn how we can use another point to, I need an a coefficient. In the end, I should have y equals to something times x minus 2 quantity squared minus 3. I've got to figure out what this a is, and I'm going to use this other point. This is a xy point, ordered pair. So what if I plug in 3 for x and -2 for y and solve for the leading coefficient? Here's what I mean. I'm going to plug in 3 for the x and -2 for the y. And I'm going to use my skills from chapter 1 to solve for a. And then to get this by itself, add 3 on both sides. And we're looking at the leading coefficient is 1. I need to write a quadratic function in vertex form. So you're going to see that y equals leading coefficient times x minus h squared plus k, but I'm going to have h replaced, k replaced, and then I have the leading coefficient being a 1. Notice how I didn't write it? Because if it's just a 1, it's not necessary to write if your leading coefficient is a 1. So in this next example, again, let's start with the vertex form and then figure out, okay, how are you going to plug in your vertex? I'm going to replace the h. I'm going to have x minus 2 in parentheses. And then k keeps its sign, so I have plus 4. And then I'm going to use the other point in the xy place to figure out my leading coefficient. And I solve from there. So in this next example, notice what it asks. Write a quadratic function in intercept form for the parabola. So wait a second. Intercept form, you actually have that in your composition notebook as one of our formulas to remember. Intercept form looks like the following. This P and Q were the 2 intercepts we would get. Typically we would think this point is at -2. But notice this point is saying that it's at -2, 8. Wait, if this is at -2, then that means the indices are changed. The indices are going by 2's instead of just by 1's. So that if this is -2, that means one of our x-intercepts is -4. But when I plug it into the equation, it's going to become x minus -4, otherwise known as x plus 4. And this is a +2. And in the equation, it'll be x minus 2. So notice how the equation switches. So using this point, and notice how we should plug in -2 into both x's. Again, we want the quadratic function in intercept form. So to recall intercept form again, I'm going to want an equation in this form. I'm going to find my P and Q by looking at the graph, looking for the intercepts. Ooh, wait a second, these intercepts are not perfect. But notice how this point is labeled 2, -6. So if I were to adjust my indices, they're saying this is a 2, and in order for this to be a 6, -6, the indices must go by 2's. So one of our intercepts perfectly between 2 and 4 would be a 3. So one of my intercepts will be a 3 up here. The other intercept will be a 1, actually a -1. If you plug in a -1, what would be x minus -1? So we've got one of our x-intercepts looking like x plus 1, the other factor looking like x minus 3, and then I have to figure out this leading coefficient. So my answer will contain all of this of what I'm seeing except a number for A. I've got to figure out A. The only way to do that is use this point. So -6 will be plugged in for the y coordinate. 2 will be plugged in for the x's.